Welcome everyone in the series of lectures of statistics, and this is lecture 8. And this lecture is also dedicated towards probability because even the previous lecture was on probability. So there would be 2 to 3 sessions on probability. What we are trying to do, first understand what we are trying to do. In the previous session, we discussed about what are the different nomenclatures of probability. We discussed about the events in the probability. So we are trying to find out a blueprint that will keep handy for the first 10 to 20 questions. I'll keep this blueprint handy for the first 10 to 20 questions of the probability. And after that, you will build a very good understanding. You will have a very good intuition to solve the probability question. You don't have to remember the formula. You don't have to keep an eye whether it is a dependent event or independent event. It would be a very intuitive exercise when you solve the probability question. But yes, for the first 10 to 20 question, you have to keep this blueprint handy. And in the series of lectures, this 2 to 3 lectures, which is dedicated towards probability, is to create that blueprint for you. Okay. And in that blueprint, one thing which is critical to understand the rules and regulations of probability. And when I say rules and regulations of probability, I wanted to say that what are the different mathematical operation that you have to remember when you try to find probability for two events. And for that, today we are in and rule and or rule. So we'll discuss and rule and or rule. Let's jump into and or rule. So assume there are two events, A and B. And A and B could be any two events. It could be stock price rising, stock price falling, market rising, market falling. It could be anything. And you are interested in what is the probability of A and B happening simultaneously. You are interested in probability of A and B happening simultaneously, where probability of A is aware, probability of B you know. Okay, so the universal formula to find probability of A and B happening simultaneously is probability of A given B into probability of B. Please remember, this is the mistake most of the students do, that they keep it as pure probability of A, pure probability of A into pure probability of B. No. If it is dependent event, yes, this is the formula, or you don't have any information related to event, this is the formula. So this is the universal formula, okay, that you will apply to find probability of A and B, irrespective of the event. If you have no information about the event, this is the formula that you will apply. If the information, yes, this is a dependent event, you will apply this formula. That's it. But if you know that the two event A and B are independent event, or if you have an intuition that A and B are independent event, yes, then the formula changes, and that is the pure probability of A into pure probability of B. And if it is a mutually exclusive event like day and night, what is the probability of day and night happening simultaneously? We all know that is 0. So for mutually exclusive event, you have to put down 0. Okay. Uh, so these are the three version of formula in and rule for or. So in or, we are trying to find out what is the probability of A or B, A or B, this or this. Any one of them you are interested in. So again, there are three version of formula. But if you see the formula carefully, the universal formula is probability of the universal formula for probability of A or B is probability of A, which is the pure probability of A, plus pure probability of B minus probability of A and B. So this is the formula of OR rule, or this is the formula that you will use when you are interested in this event or that event probability. Or, but please understand there is and formula in OR rule. So actually OR rule doesn't have different version of formula, but we just discussed that there are different version of formula for dependent, independent, and mutually exclusive, and that will impact the OR rule, because in OR rule you have AND rule hidden. So therefore, probability of A plus probability of B, probability of A plus probability of B, probability of A plus probability of B in whatever version of formula we'll discuss for different events, this section remain constant. But minus probability of A and B will change dependent upon whether it is dependent event, independent event, or mutually exclusive event. So let's see, probability of A plus probability of B minus probability of A given B into probability of B, because that is the formula for dependent event. Again, probability of A plus probability of B minus probability of A into B, because this is the formula for AND for independent event. Again, probability of A plus probability of B minus 0, because this is the formula for AND for mutually exclusive event. And that's it. That is all you have to remember in AND and OR rule. Now, let's see how would we apply it. So we have some questions, and if you solve these questions properly, you will have a good understanding of application of and or rule. Definitely these questions are not very complex, but it will give you a very good intuition how you should apply and or rule. So for the first question, what is the probability of India winning the Cricket World Cup? And so you're interested in two events happening simultaneously, Italy winning the Football World Cup. The question is, are they independent event or dependent event? They're independent event. The reason is you're talking about two different country. You're talking about two different genre of sports. And there are two different association related to India cricket and Italy football. So definitely they are two independent events. They will not mention this in the question. Now, this is a very simple question. So you should have an intuition of whether two events are independent or dependent event. These are independent event. So you are interested in what is the probability. You are interested in finding what is the probability of A, which is India winning the Cricket World Cup, and what is the probability simultaneously happening of Italy winning the football World Cup. Because they're independent event, you will use the formula probability of A, which is the pure probability of A, into probability of B, which is the pure probability of B. Do we have these probability mentioned? Yes, 60%, 30%. So the answer would be 18%. Solved. Let's look into the second question. What is the probability of Tesla stock price rising? And again, and rule. S&P 500 value rising. Are they independent or dependent event? They are dependent event. Why? Now this is important for all the students who are sitting for CFA and FRM examination. S&P 500 is market index, which represent market or economics of the country. If the market rises because of any positive sentiment, then it will impact the stock prices. So stock price of Tesla, stock price of Meta, stock price of Microsoft, each one of them will get impacted. So therefore, these two events are dependent event. The problem is they will not mention this in the question. So the formula for probability of A, which is Tesla stock price rising, and B, which is S&P 500 value rising, will be probability of A given B into probability of B. Now let's see whether we have the information here or not. Do we have the information of probability of A given B and probability of B? Probability of B is given, that is 90%. But do we have the probability of A given B? No, we don't have that information. So in the multiple choice question, there would be one option which says insufficient information. And all the CFA and FRM aspirant will tick this. All the CFA FRM aspirant will choose that option. Okay. But what if you have this information, that is probability of A given B is equal to 30%. If you have this information, then the probability of A and B is equal to probability of A given B, that is 30%, into probability of B, that is 90%. So 30% into 90% is 27%, right? And that is your answer. Third question, what is the probability of India winning the World Cup, or, so you will apply or rule, and Italy winning the Football World Cup? So what is the formula? Probability of A or B is equal to pure probability of A plus pure probability of B minus probability of A and B. Now because it is probability of A and B, it depends upon what? Events. So is it an independent event combination or a dependent event combination? Independent event. So it would be pure probability of A into pure probability of B, because that is the formula for AND rule for independent events. Correct? Okay. So do we have these information? Do we have probability of A? Do we have probability of B in this question? Yes, we have probability of A, that is 60%, plus probability of B, that is 30%, minus probability of A and B, which is probability of A into probability of B, only because this is independent event, that is 60% into 30%, that is 18%. As in this value is 18%. So 90 minus 18% is 72%, which is the final answer for this question. Okay. Last question. For the last question, please change this from 90% to 30%. Otherwise, you will get incorrect answer. Okay. The last question is probability of Tesla stock price rising and S&P 500 value rising. I will recommend you to pause the video and solve this question. Okay. So the probability of the probability of A, which is Tesla stock price rising, or B, which is S&P 500 value rising, is equal to probability of A plus probability of B minus probability of A and B. And because these two events are dependent event, therefore probability of A given B into probability of B. Now the question is, do we have this information, probability of A given B? No, not in this question, but it has been provided in the previous question. Okay, so let's use that probability of Tesla stock price rising given S&P 500 value has risen is 30%. So probability of A is 70%, probability of B is 30%, minus probability of A given B, that is 30%, into probability of B, that is 30%. So let's solve this question. 70% plus 30% minus 30%, which is probability of A given B, into probability of B, that is also 30%. So the answer is 100% minus 9%, that is 91%. Okay. Now the question is why we are subtracting something in OR rule. The reason is, let's see with this example, question number 3. When I say probability of India winning the World Cup, that is 60%, I'm aware of it. But when I say the probability of Italy winning the World Cup, that is 30%. If I do 60 plus 30%, because we are interested in probability of A or B. So 60% plus 30%. Do you observe that you're doing a double counting of the intersection? See, I'm repeating again. Probability of A, you counted this section. Then you again counting this section when I say probability of B. So there is a double counting of this intersection section, which is the probability of A and B happening simultaneously. This is the probability of India winning the Cricket World Cup and Italy winning the Football World Cup happening simultaneously. This is an intersection point. So you should remove it. So this would be 60% plus 30%, definitely fine. But you should remove this section. And to remove this section, you say probability of A and B. And that depends upon whether it is independent, dependent event. Okay. Only for mutually exclusive event. Only for mutually exclusive event. What if this two cannot happen simultaneously? Then I would say 60%. And this 30% will be another circle. They will never overlap because they are mutually exclusive event. So therefore you don't have to subtract anything. But this is only true for mutually exclusive event. Okay. With that, we have completed AND and OR rule. In the next section, we'll discuss the Bayes theorem and total rule. And I assume that would be the last session for probability. And after that, we'll enter into probability distribution. But we'll try to gauge that in the next section because then we will only be able to understand whether we need any more sessions or lectures in probability. So with that, we'll end the section in the lecture here. Thank you. Have a nice day.